Okay, after analyzing the OGV mechanism within the Theora texture object, I discovered exactly where the writes were occurring. I've analyzed this before in some of the previous videos. This execute. This is when this is a thread work item. These are used and distributed directly to the whatchamacallit to the thread pooling, so that work items are kind of balanced out. But hold on, I'm gonna start the application here. Waiting for it to start. Yeah, I have multiple screens, so it's actually showing up on a different screen right now. See, I'm gonna start it. I'm just loading an empty mission right now. It's loading the mission file. It should start here in a second. Okay, so the application has paused. Here we are in read address of frame. This right here is just telling it that it's gonna be getting one stream. M frame stream is what actually holds the frame data. This right here is really important uh, in regards to things that we'll be doing in the future that are not, Theora related or whatever. So this, uh, I'm gonna step over this, come down here. Okay, so this get Theora is just getting a pointer to an OGG Theora decoder that was created during initialization. As you would imagine, there's a height and a width member function, or method rather, uh, in the decoder itself. So if I step, this is important. Notice that rect here is being set to M frame, M locked rec, and M frame is uh, whatchamacallit, it's actually part of the class itself, so it's part of this. So if the rectangle is set, meaning that if it was able to actually, grab the rectangle pointer, um, it'll basically try to write the the frame data into the bits. So after this rectangle, which is pointing to M framed or M frame M locked rectangle, will contain the data which was in the frame. So again, OGG Theora frame, M frame stream get source stream, which is basically getting a pointer to the stream. It's reading from the stream one frame element, then it does these assignments, gets that rectangle, and then copies the frame data into the bits. It's a literal mem copy, just straight up mem copy. So just copy this with this size. Okay, so let's go ahead and step over. Step over, step over, step over, step over. Okay, so now you can see we're actually in the mem copy. This is where the memory is actually being copied. Down here you can see M frame, which was the frame that we were working on. You can see M frame number being assigned directly from frame, so that when it's actually used at the bottom here, those fields are actually already filled out. If we look at frame, you can see that the only things inside a frame are raw data, frame number, frame time, frame duration. And I have M frame here, which is basically what's being swapped out. You have texture, locked rectangle, frame number, frame time, frame duration. You can see that they're empty here. They're actually, unset, and that's because I haven't stepped through them yet. The data has already been copied in. It's just that these values haven't. Now, if I step, you can see that this is the first frame. If I step, you can see that that's the frame time, and you can see that that's the frame duration. Kind of cool. So if we step one more time, it basically allows frame to be reused for the Theora decoder here. And this is where things are actually basically processed. So frame stream on arrival, go to definition. And you can see it basically it's setting everything up. Go back. And it'll just loop and loop and loop. Pay attention down here. You can see now we're on frame 2. It'll do this for every single frame in the stream, as long as there are frames for processing. And so yeah, that's it for this video. I just figured show this, kind of help it make a little bit more sense. That's it. All right. Oops.